Hello, everyone. So today we're going to be talking about how to write a good experimental method section. So despite what most people think, it turns out that the whole point of your experimental methods should be to make your paper much more understandable, not so much less. So a good general summary of the objectives of a method section is to provide everyone enough information to replicate exactly what you did. But then here comes the second part of the question. What's your audience? So generally, our idea of an audience is going to be the quote unquote expert. So this is someone who might not be brand new to the field, but definitely doesn't know what you did. So a good general summary for who you might consider to be an expert would be, say, another member of the PChem class who isn't part of the lab, or alternatively, another, say, junior in biochemistry. They have a familiarity with most of what you do, but a lot of the details, a little bit less so. So that's a good general benchmark for you to use for the level of expert when writing in this class. Now, one of the big things you're going to be doing by assuming that your reader is an expert is that assume that they're familiar with a lot of the basic lab techniques, equipment operations, and programs. So a lot of the times you'll go ahead and just say what techniques were performed, what equipment was used, and what software packages you used. But you often don't need to put in all of the details of how it was used. That said, if there's such information like, say, you're doing a titration, you might want to specify what type of burette was used. If you're using a UV vis spectra, what region what region of the spectra are you focusing in on? And are you, say, doing single wavelength or broad spectrum wavelength? And similarly, whenever you're using a software package, make sure to specify which types of keywords you use, because just saying that I used program X won't often provide enough information for someone to replicate what you did. And again, one of the big things that you should make sure to put focus on is kind of the details of exactly how you conducted your work. So a good example is exactly what chemicals you used, what concentration, who was the manufacturer, exactly what procedures were used. So if you're using aliquots, what size, and again, instrumentation settings. So again, if you're only using the default settings, you often don't need to give a full set of details. However, as soon as you start using any non-default settings, make sure to specify exactly what you did. And again, here's a aspect that's often missed in a method section, and that's that it should include exactly how your data was analyzed, as well as how it was collected. Now, to make all of this worse, not only do you need to provide all of this information, which is quite a lot, we also want to try and make this as readable as possible. And this is something that some people tend to neglect. And that's to make sure you use a narrative form, because it turns out people aren't so good at internalizing a large stream of facts. They're much better at internalizing a narrative. So if you can go ahead and put what you did into some sort of narrative structure, using some sort of temporal alignment of I did this and then I did that, can often be very helpful. And again, one of the things you should watch out for is, just like some of the other sections, it turns out every journal treats their method section a little bit differently. Most journals typically want to put their method section directly after the introductions. This is essentially the classic location for a method section. And we're going to follow this scheme when we're doing a communications, partially because our method section will be greatly condensed down to a single paragraph. However, for a full paper, which is what we're going to spend more time on, we're going to go ahead and move our method section to the end of the paper. And this essentially is a way to make sure it doesn't interrupt the narrative flow. And so again, it's worth noting that some journals, and more specifically some subdisciplines, definitely tends to prefer this method. And it's become increasingly common, especially in organic chemistry. And because more and more journals have been making this decision, we're going to essentially move with the times and try and put our method section at the end of the paper. And again, when we're working with our communications, we're going to try to shorten down our method section. So truncate it to essentially the bare minimum of what somebody needs to know of the outlines of what we did. Now, what's worth noting is that that even if I have a communications, which usually has a lot less data than a full paper, I still need to convey the exact details of how my data was collected and analyzed. So one of the more popular moves has been to make use of the growing importance of the supplemental information. So you may notice in our article templates, we do include supplemental information. In practice, this is going to be published alongside, but again, in a separate document from the main paper. And this is essentially for those nerds who want to know more about the details of how the work was done and some of the nitty-gritty. And so, especially when you have a communications, which is trying to hit the highlights and maybe not get slogged down in the details, supplemental information sections have become incredibly important. And thus, not surprisingly, they become a lot more important with communications just because we're trying to keep things streamlined. So this is essentially some of the big picture of what a method section kind of is and what kind of formats it follows. However, in order to get like a good a good groove of how to write a method section, it's good to try and essentially follow a classic form. So most method sections are written in the following order. You go ahead and start off by describing exactly what materials were used. So think of this as if you have as the best recipes in a cookbook. Start off by telling the cook exactly what materials they need to go ahead and gather before they start working. So it's more or less the same thing here. And this is going to include the identity of the material, so exactly what chemicals, the purity / concentration, because if I need to prepare 6 molar HCl, it's going to be very different from 0.1 molar. And again, if you have a rough idea of general volumes, this can go along with this idea of purity. But here's another important thing, which is the source of all chemicals used. And this is something that in teaching labs, we're often a little bit kind of lax on. But the source of a chemical can be very important, as there's been numerous cases where only a chemical precursor from a certain manufacturer actually works. And the reason why is almost inevitably cross-contamination or a lack of enantiomer purity. So again, making sure you specify the source can be very important. If you're unsure of the exact source, but you know it was purchased, the general phrase is was obtained from a commercial source. However, if you can get more details, please do, as this is going to be very helpful. Next, when you after you know what materials were used, you're essentially going to go through the experimental methods used. So this is going to be essentially the full step-by-step procedure. And so one of the important things to make sure you include along with this experimental methods and procedure is when you're dealing with equipment, make sure you give the exact make and model of any instrumentation, because just like source and purity of a chemical can make a difference, the exact model of, say, a UV vis spectra may indeed make a difference. If nothing else, if somebody wants to know the exact accuracy or precision of a piece of equipment you're using, they can essentially look it up online. Now, one of the things that we often don't need to deal with in the lab, but can be very important in the real world, is to make sure to include any information about sample collection. So if you have to go ahead and collect your samples from the wilds, or even just from the air, make sure you give a full list of exactly how all samples were obtained, and this usually immediately follows the materials used. Also, make sure to include any synthetic procedures, analytical protocols, and quality control. And once you've essentially done that, once you've essentially done that, you'll often include, and while doing this, again, make sure to include the make and model of any instrumentation, but you don't need to include common lab equipment. So for example, if I'm, say, um, using a set um, of beakers, I don't need to make sure to say what beakers I used. And if I'm using, say, something like a volumetric pipette, then usually all I need to say is the size and whether it's class A or not. Now, one of the other important things to remember is we also are going to need to describe any numerical methods used. So this is essentially going to be all about analysis. So if you're doing computational methods, so if you're doing any sort of quantum mechanical calculations, which we're going to do a little bit at the end of the semester, but much more extensively in PChem 2, or if you're just going to do statistical analysis, which is going to almost perpetually be the case for a lot of our work. Make sure you essentially describe how the data was collected and analyzed, which with, again, as before, if you're using a specific software package, make sure to provide that along with any important keywords and list any sort of statistical methods used. And again, when you're using software packages or statistical methods, please make sure to cite them unless they're very common methods such as the student's T. So this is, again, a lot of information. So let's go ahead and take a look at a paper. So I went ahead and took an excerpt from a discussion of essentially an analysis of herbicides in soil, and essentially how exposure to sun can essentially break them down. So the full article is going to be on Blackboard, but you can find the full citation here. So you'll notice the first thing they do is essentially list all of the chemicals being used. At this point, it's fairly easy because almost all the chemicals were obtained in the relative pure state, and most of these were not commercially provided, but instead provided from a collaborator. And again, I would like to see a little bit more detail from here because they just give the chemicals being analyzed and not all of the chemicals that are needed to, say, analyze them, such as common reagents. Then the next step is, well, in this case, it's sample collection. So they're telling you exactly how they collected any soil samples that were being analyzed, as well as information of exactly where they were obtained from. And then, after you collect the samples, it turns out that you need to essentially store them and bring them home. So essentially, storage can be another important piece of information. For example, it's important to know they may have been stored in polypropylene, as some of these chemicals may have unforeseen chemical reactions. And then they go through the full form of analysis. And in this point, it's mostly simple chemical analysis, so general procedure informations. There's essentially just enough procedure information that you should be able to replicate this storage method. And then turns out they need to do the extraction of their herbicide residues from the soil. And so they go through a series of procedures with, again, enough detail that you can follow, but not in gratuitous step-by-step detail. For example, they use solvent extraction with exact information of what solvents were used and how, as well as what major pieces of equipment were used. But again, for common pieces of equipment like pumps and vacuum degassers, again, you often don't need to provide the exact identity of the piece of equipment, but as soon as you're talking about analysis instrumentation, such as their photodiode array, they give the information of exactly of the exact piece of equipment. And again, you see this repeated with the following procedures, such as running a column with the exact details of how to set up the column, and general ideas of the retention times for the chemicals that were observed. And then it turns out that there's also numerical analysis, even for a strictly experimental paper, because they still need to fit it to a basic model. So if you're trying to fit your data to an equation, make sure to provide the equation and emphasize all of the key variables involved. And again, basic idea of the statistical analysis form being used. In this case, simple curve fitting um, and linear models were used, so they keep the detail fairly minor. If you're doing a more detailed analysis, make sure to provide enough information. And if you're using a software package such as R, where you have to write code, make sure to either provide the exact code used in the supplemental information, or if you're using a pre-constructed package, to cite the package directly. So hopefully this gives you an idea of generally how you can write a method section. Next time, we're going to begin our examination of how to write a results and discussion section. But we're going to start by first talking about how to make a good figure. Until then, take care.